Hello and welcome. Today, we are going to explore a fascinating concept in thermodynamics known as the inversion temperature. Have you ever wondered how we turn gases like nitrogen or oxygen into liquids? It's a process that relies on a very specific rule, and that rule is all about this special temperature. To get started, we need to understand something called the Joule-Thomson effect. Imagine you have a gas under high pressure on one side of a barrier, and you force it through a tiny opening, like a porous plug or a valve, into a region of low pressure. This process is called throttling. When the gas expands like this, its temperature can either decrease, increase, or stay the same. This change in temperature is the Joule-Thomson effect. The big question is, what determines the outcome? It all comes down to the forces between the gas molecules. Real gases aren't ideal, their molecules attract and repel each other. When a gas is below its inversion temperature, the attractive forces between molecules are dominant. As the gas expands, the molecules have to work to pull away from each other. They use their own internal energy, specifically their kinetic energy, to do this work. Since temperature is a measure of the average kinetic energy, using it up causes the gas to cool down. This is the cooling effect we need for liquefaction. However, if the gas is above its inversion temperature, the molecules are already moving so fast that the attractive forces are negligible. Instead, the repulsive forces play a bigger role during the expansion, and the overall effect is that the gas actually heats up. So, the inversion temperature is the critical dividing line. It is the precise temperature for a given gas where the Joule-Thomson effect switches from heating to cooling. Below this temperature, expansion causes cooling. Above this temperature, expansion causes heating. At exactly the inversion temperature, there is no temperature change at all. This is incredibly important in the real world. For example, the inversion temperature for hydrogen is about 202 Kelvin, minus 71 degrees Celsius, and for helium, it's about 40 Kelvin, minus 233 degrees Celsius. This means if you take hydrogen at room temperature and try to cool it by expansion, it will get warmer. To liquefy it, you must first precool it to below minus 71 degrees Celsius, and only then will further expansion make it colder and eventually turn it into a liquid. So, in essence, the inversion temperature is the gatekeeper for gas liquefaction, telling us whether expansion will act as a refrigerator or a tiny heater. I hope this explanation helped demystify the inversion temperature for you. Thank you so much for watching. If you found this video useful and want to learn more, please consider liking this video and subscribing to the channel. Your support is greatly appreciated and helps us continue making educational content. See you next time.